So now let's understand derivatives. Okay, so now we know what are functions. It is one-to-one relation between the input variable and output variable. And then what is continuous function? The function whose graph can be drawn without lifting the pen. Okay, so now see, what I am doing is, let's say I am performing some kind of motion. Okay, let's say I am moving, okay, from one place to some other place. So on x-axis I am plotting time, and on y-axis I am plotting my position. What do I mean by x and y? Horizontal axis and vertical axis, not x and y. Horizontal axis I am plotting time, and on vertical axis I am plotting what? My position. So let's say I get a curve like this. Okay, I get a curve like this. So after that, suppose I want to find out my speed. Let's say from this point to this point. So how do I find? So from this position, let's call it x. Okay, this is very thick. From this position to this position, I want to find out my speed. So what do I do? What is speed? Anybody?
Distance by time.
Distance covered divided by time taken. Right. So I want to find out my speed. Okay. Or let's say velocity. So velocity will be just displacement upon time. What is difference between distance and displacement? Anybody knows?
Velocity is equal to displacement by time.
Yeah, that is true. So the difference between the displacement and distance.
Displacement means shortest
Displacement is shortest distance
distance.
between start point and end point. See, I wrote x1 and x2 here. We are so used to this horizontal axis calling x. Okay, so this is some time t1 and t2. All right, so from time t1 to t2, not x1, x2. I want to find out my speed. So what I will do is I will draw a perpendicular on this curve. It meets at this point, and from there I will draw another perpendicular on x-axis. So it meets at this point. So this is my position at time t1. Similarly, I will find position at time t2. Okay, so this is my position at time t2. So if I take x2 minus x1, so how much is x2? This much is x2. Okay, this much is x1. So this much distance from here to here is x2 minus x1, right? So if I take x2 minus x1 divided by t2 minus t1, okay, t2 minus t1, what do I get? I get the speed. Okay, so here x is a function of time. Okay, so we already learned about the function, right? So here x is written in terms of time. Okay, so x depends on time, so it is function of time. For every value of time we get a particular value of x. Okay, one and only value of the position. Okay, so can you be at two positions at the same time?
No.
Okay, so we get only one value of position. Okay, so x is function of time, right? Now see, I want to find out speed. So it is x2 minus x1 divided by t2 minus t1. Okay, so see, if I draw a line joining these 2 points on the curve like this. So do you know how to find out slope of the line? By the way, this line is called as which line?
Slope.
No, this is called as secant line, right? You have an arc and you draw a line joining 2 points of arc. Okay, that's not important. See, now we draw a perpendicular from this point on the curve. It meets at this point on the graph, and we draw perpendicular from this point, okay, on the graph. So it meets at this point. So we join those 2 points. Okay, so how do we find slope? Is we take rise over the run. Now what do you mean by rise over the run? So change along the vertical axis divided by change along the horizontal axis. That's my slope. Okay, so these points, they can be written as, this is t1 x1, and this is t2 x2, right? These points. So x coordinate is t1, y coordinate is x1, not x and y, horizontal and vertical. For this one, the horizontal coordinate is t2, the vertical coordinate is x2. Okay, so what is change in the vertical direction? That's called as rise. Okay, change over the horizontal direction is called as run. So this is rise, this is run, and slope is known as what? Rise over run. So what will be that? This much distance divided by this much distance. Okay, so distance meaning this much length divided by this much length. Okay, so it is x2 minus x1 divided by t2 minus t1. So this is clear.
Yes, sir.
This is clear, Veera. Okay, so what I am doing is I am finding the speed between t1 and t2. And what is the speed? So if I draw a line like this, okay, so I take those points on the curve, the point corresponding to t1, the point corresponding to t2, I take them on the curve, then I draw a line passing through those 2 points, and the slope of that line gives me the speed. Okay, after that, now what I will do is I will take t2 closer to t1. Okay, so see, what I am doing is I am taking t2 closer to t1. So let's say this is my t2 now. Okay, so let's call it t2 dash, and I want now the speed between t1 and t2 dash, t2 prime. Okay, so what will be that? So if I take this point and this point, okay, this point and this point, and if I draw a line like this, okay, then slope of that line will give me the speed between these two times. Is that right? Yes, no?
Yes, sir.
Okay, so the line will become like this. Now can you observe something here? So as the difference between the initial and final time becomes lesser, okay, the difference on this horizontal axis becomes lesser. What happens? This line whose slope gives you the speed, it approaches closer to the curve, right? Earlier this was the line, now this is the line. Okay, now if I take, let's say, another another point, okay, another time, let me call this t2 double dash or double prime. Okay, and now I want the speed between t1 and t2 double prime. Okay, so what will be that? So again I will plot the point corresponding to T2 double prime on the graph. So it meets at this point, okay, and then I will draw a line from this point to this point on the graph, okay. So I am drawing the line, and now can you see? Okay, let me choose a different color.
Yes, sir.
So what's happening? Can you see? As the time
Yes, sir.
difference, yeah, as the time difference becomes smaller and smaller, the line whose slope gives you the speed, it approaches closer and closer to the curve, okay, the graph between x and t, okay. And what is x? It is f of t. It's some function of t. All right. Now you can imagine what will happen if time difference is made very very small, vanishingly small. Okay. So now, what do I mean by this? Let's say I am performing some motion and I want my speed at some particular time. Okay. So very short, in split of second, I want the speed. So what will be that? It will be, anybody? So what will happen to this line which gives you the slope? See, the line is approaching closer and closer to curve. So if time difference is made very very small, almost zero, what will happen to the line? Okay, so let's say I cannot show almost zero over here, okay, but I will draw very close point. Okay, still you can see it's a little bit far apart. Okay, so this is, let's say, t, this is t2, t2 dash dash dash. Okay, so this is my time. So now what's happening? See, the curve and the line whose slope gives you, what? The speed. They are overlapping on each other, onto each other. Okay, so now if this time difference is made even smaller, okay, almost zero, what will happen? That line will be tangent to the curve. So everybody knows what is a tangent. Is this point clear? Let's say I want the speed between this and this point, they are very close. So the slope of this line, okay, which touches the graph at one and only one point, okay, the slope of that line gives me the speed. Okay, so this is called as the derivative now. Okay, so now let's see what is the derivative. So what is derivative? So let's say you take some function. So this is some function, okay, that you are plotting. This is function of, this is x, which is function of t. Okay, x which is function of t. On horizontal axis we are plotting time, on vertical axis we are plotting x. Okay, so now for particular value of t, let's say you want change in this change in this function, okay, with respect to change in this variable t. Okay, when change in t is made very very small, okay, when change in t is made very very small, so what do you get? So that thing gives you a slope of tangent line to the curve, and that is called as derivative. Okay, that is called as what? Derivative. So see, now what is derivative of f of x? Sorry, f of, we took t as a variable, so f of t with respect to t, so it is f of t plus delta t minus f of t divided by t plus delta t minus t. Okay, so let's see this in the graph. So this is my t, or you can call it t1. Okay, so this is my t, this is t plus delta t. Okay, and then you find the values of x corresponding to t and t plus delta t, right? So this delta t is very small. This delta t is very small. How small? It is almost zero. Okay, so how do we show that? We write as limit delta t tends to 0. Okay, let me make a space for it. So we write it as limit delta t tends to 0. So we take one value of a variable, then another value of a variable, but those two values, they are spaced with very short interval. Okay, so that interval here is delta t. So this much interval is delta t. So this delta t is very, very small. Okay, this delta t is very, very small. So then you find the values of function of this variable at this time and this time. Okay, so at t and at t plus delta t. Okay, so this is your x, which is x1, this is x2. So this is equal to what? This is equal to f of t. This is equal to f of t plus delta t. Is that clear?
Yes, sir.
Okay. So when this interval is made very, very small, vanishingly small, we say vanishingly small meaning it's almost zero, then the line whose slope gives us this thing, okay, the change over the vertical axis divided by change over the horizontal axis, the line whose slope gives us that it will be almost tangent to this curve. Okay, and then we call that ratio as a derivative. Okay, clear? Okay, so let me define it just once again. Okay, so what is derivative? Derivative is slope of tangent line to the curve. Okay, so what does derivative represent? It represents the slope of tangent line to the curve. Okay, now in terms of physics, let's say, so we are plotting here, we have taken this example, we are plotting the position on the vertical axis, time on the horizontal axis. Okay, so if I find change in position, change over the vertical axis divided by change over the horizontal axis, what do I get? I get the average speed, right? Now if I make time interval very, very, very small, okay, let's say I want to find out speed at a particular instant, okay, or velocity at a particular instant. So when time interval is made very, very small, how small? How much small? Almost zero. Then this ratio, the change in the position divided by change in time, when time is almost zero, it gives me the instantaneous velocity. Okay, so what is instantaneous velocity? Instantaneous velocity
At a particular instant.
at a particular instant. So I will denote it by V now. So it is limit delta t tends to 0. So this time interval in which we are finding the velocity, it's almost 0. Okay, so now I will just represent it by x only. So x at final time, which is x plus t plus delta t, minus x at the initial time t, okay, divided by this final time minus the initial time, which is t plus delta t minus t. Okay, this gives me the velocity, and this thing is called, okay, this thing is called as what? It is called as derivative of position with respect to time. Okay, and on the graph it gives me what? The slope of tangent line, okay, at this point t. Okay, on the graph it will give me what? The slope of tangent line. So what is instantaneous velocity? If you plot the graph between position and time, then the slope of tangent at any point or any time will give you what? It will give you the velocity at that time. Okay, and this thing is known as what? Derivative. So this is called as this formula that we are looking at now. This is known as the first principle of derivative. Okay, this is known as what? The first principle of derivatives. All right. So I will write it here. First principle of derivatives. So V is derivative of position with respect to time, and I will write it as dx by dt. This is how we write derivatives. Okay, dx by dt. What is that? It's derivative of position with respect to time. Meaning, if you draw position versus time graph, the slope of tangent to that graph at any time will give you what? Derivative. Okay, so limit delta t tends to 0, x at t plus delta t minus x at t, and in the denominator, what do you get? You get delta t. Okay, so is this thing clear? Is there any
Yes, sir.
confusion? Is there any confusion? So we are looking at this formula. We look at the formula in maths, right? But this is the meaning. Okay, so let's see some examples so that we understand it better. Okay, so the examples are: find derivatives of the following functions. So first, f of t is equal to t. Okay, or x is equal to t, we can say. Let's say position x is equal to f of t, which is t, and I want to find out its derivative. Okay, so let's consider first example. So I want to find out d by dt. Okay, we call it as d by dt of f of t. What is f of t? It's function of t, some function of t. So it is d by dt of, what is f of t here? T. Okay, how will the graph of this f of t with respect to t look like? You can write, we are writing that only, no? x2 minus x1 upon t2 minus t1. Okay, but that will give you average difference, right? We want instantaneous difference. Okay, so how will this graph look like? So on t versus t graph, so on x-axis I have t, on y-axis also I have t. Okay, I'm always saying, okay, I'm saying this as x and y, horizontal and vertical, t versus f of t. So how much is f of t? So what is f of t? It's t. Okay, in this example, first example. So when t is 0, how much is f of t? See, what is f of t? F of t is equal to t. Okay, so when t is 0, yeah, f of t is equal to 0. When t is 1, what will be f of t?
1,
1. Okay, when t is 2, what will be f of t?
2,
2.
2,
Okay, when t is 3, f of t is also 3. So graph will look like this. It will be aligned like this. Okay, can you tell me how much will be this angle? It will be 45 degrees.
45 degree.
Yeah, it will be 45 degrees. Okay, so now how much is slope of this line?
Z,
No, no. Slope of this line is not 0. There is some slope, no? Line is slanted, right? Yeah, slope of this line is equal to 1. Okay, that means derivative should be equal to what? It should be equal to 1. Okay, see how does this work? So this is our problem. Okay, we want to find out d by dt, that means derivative of f of t, and as an example we have taken f of t equals to t. So d by dt of t we have to find. Okay, so now this is equal to limit delta t tends to 0. Our first principle, limit delta t tends to 0. So f of t plus delta t minus f of t divided by delta t. Okay, so when this variable is t, the function of that variable is also t. When variable becomes t1, let's say, the function is also t1. When it becomes t2, the function will become t2. When it becomes t plus delta t, what will be the value of function? The variable itself is a function. Okay, so f of t is equal to t. So f of t plus delta t will be equal to t plus delta t. Right? Right or wrong?
Right.
Are you getting this?
Yes, sir.
Okay, that's what we did. No, for t equals to 1, okay, f of t is also 1 because f of t is equal to t. So when t becomes 2, it becomes f of t becomes 2. So let's say this is t, okay, and this much distance is this much difference is delta t. Okay, this is t plus delta t. What is t plus delta t? For an example, let's say it is 3. So t is 2, delta t is 1. So t plus delta t is 3. Okay, so what is f of t plus delta t? It is also 3. So f of t plus delta t is also t plus delta t. Okay, so this is equal to t plus delta t minus t divided by delta t. Oh, sorry, divided by delta t. So now you can see some cancellations happening. So this t and minus t gets cancelled out. So what are we left with? Delta t upon delta t. And what is delta t upon delta t? It is
1.
1. Okay, so this is equal to 1. So what do we get from here? D by dt of f of t. But what is f of t? It is t. It is equal to 1. Okay, so dt by dt is 1. Similarly, you change variable from t to x. What will be dx upon dx? 1. Okay, because it is just name of the variable, right? You change variable from t to y. What will be dy upon dy? 1.
1.
Okay, so derivative of a variable with respect to itself is 1. Okay, you got this 1 row over here. Okay, shall we move on to next example? Next example
Yes,
is
sir.
t square. Is this clear? Is there any question in this?
No, sir.
Okay, so now as we see some more examples, you will understand the pattern. Okay, so next example is f of t equals to what? T square. This is our second example, and we want to find out d by dt of this. Okay, so let's just write down our first principle of derivatives. Okay, so d by dt of this f of t, which is t square. Okay, function is now t square. So just write down the first principle of derivatives. Limit delta t tends to 0. So it is what? F of t plus delta t minus f of t divided by delta t. Okay, and now let's substitute the value. So how much is f of t? f of t is t square. So what will be f of t plus delta t? So in place of t, you have to place t plus delta t. Okay. So limit delta t tends to 0. F of t plus delta t is t plus delta t square minus f of t is t square upon delta t. See, f of t is t square. So f of t plus delta t. Sorry, some other value of t. Other value is t plus delta t. Okay. When variable is equal to t, the function gives t square. When you put variable equals to t plus delta t, it will give, the function will give what? That value square. So it is t plus delta t square, right? Okay. So now we have got this bracket square, so we can expand it. So limit delta t tends to 0. We are getting t square plus 2 times t multiplied by delta t plus delta t square minus t square divided by delta t. Okay. So what's getting cancelled here? What is getting cancelled?
T square minus T.
Yeah, t square and minus t square will get cancelled out. Okay. After that we'll divide by delta t. Okay. So if I divide by delta t, this delta t. So this delta t upon delta t will give me 1. But here I have delta t square divided by delta t. It will give me delta t. Okay. So I'm left with limit delta t tends to 0, meaning delta t approaches to 0, almost goes to 0. 2 times t into 1 is 2 times t plus I have delta t. So what I have done here, I have just divided, okay, this thing and this thing by delta t. Okay. And then what I will do now, so this delta t is very small. Okay, that's what we are saying when we are writing limit delta t tends to 0. It means that delta t is very small, almost approaches to 0. So we'll neglect this. All right. So if we neglect that, so when we neglect this, it means that we are applying the limit. Okay. So we get what? 2 times t. Okay. What function's derivative is this? D by dt of f of t. And what is f of t?
T square.
T square. Okay. So d by dt of t square gives me what? 2 times t. Okay. You got this relation. Okay. Yes.
Yes, sir.
Veera, is there any question? You said no, sir. Yeah. What question do you have? Veera, your question? No question. Okay. Actually, guess your mic is not working or there is some network issue. Anyways, so after this, we'll see another example. And okay, we'll see another example. So f of t now is equal to t cube, right? So I want to find out derivative of this. This is just to get familiarized. Okay. So let's write the first principle of derivatives. Derivative of f of t with respect to t is limit delta x tends to 0, f of t plus delta t minus f of t divided by delta t. Okay, so let's do this once again. So limit delta t tends to 0. What is f of t plus delta t? What
T
is f?
cube.
No, f of t is
T
t
plus
cube.
delta T the whole cube.
Yeah, it will be t plus delta t whole cube. Okay, minus f of t is t cube
T cube.
divided by delta t. Okay, so what will be, all right, so what is t plus delta t cube? What is t plus delta t cube? Cube expansion, do you know? Okay, if you don't know, I will write. It is t cube plus 3 times t square delta t plus 3 times t multiplied by delta t squared plus delta t cube. Okay, this is the expansion minus t cube. Okay, and in denominator we have delta t. Now again something gets cancelled. What gets cancelled out?
T cube minus T cube.
T cube and minus t cube gets cancelled out. Okay, so we are left with limit delta t tends to 0, 3t square delta t, or shall I divide by delta t in this step itself? So delta t by delta t is 1. Okay, then I have 3t delta t square upon delta t. So delta t square upon delta t is delta t. Okay, and here I will have delta t cube upon delta t, so delta t square. So I will write 3t square. What I have done is I have divided this delta t by this delta t. So delta t by delta t is 1. Okay, plus I get 3 times t multiplied by delta t plus delta t square dividing by delta t. And then now in final step what we'll do is we'll say the delta t is very small, so small that it approaches to 0, and we'll cancel out these. Okay, we'll neglect this thing and this thing because 0 multiplied by anything is 0. Okay, almost 0 multiplied by any number will give you what? Almost 0. All right, so we'll neglect this, neglect this. What do we get? So we get 3t square. Okay, so derivative, what do we get? We get d by dt of t cube is equal to 3 times t square. 60. How come? It is 3 times t squared. T squared. Okay. Yes, Veera. All right. So after that, let's add a page. So now we got this. Okay. So I got dt by dt equals to 1. So derivative of t with respect to t is 1. d by dt of t square equals to 2 times t. d by dt of t cube equals to 3 times t square. So can you see what is happening here? This t I can write as t raised to 1. Okay. So what is happening here is when you take derivative of t raised to n with respect to t, it is n multiplied by t raised to n minus 1. See, this is the formula that we have to memorize and you can guess. Okay, so you can do an educated guess from here. How does that formula comes? Okay, how does that formula come? So d by dt of t raised to n. This is most important formula about derivatives. Okay, as far as NEET is concerned, at least, and AE too, because this is the most common derivative. So it is n multiplied by t raised to n minus 1. This is the formula that we have to memorize. Oh, I'm sorry. And you can see here, I'm sorry. So when we have t raised to 1, okay, what is value of this n? N is equal to 1. Okay, so what does this formula say? When you take derivative of t raised to n with respect to t, what do you get? So this n comes in multiplication like this, and the power of this t gets reduced by 1. Okay, so power of t gets reduced by 1. It becomes n minus 1. So here it's t raised to 1. So what happens? You can write it as derivative of t raised to 1 with respect to t is 1 multiplied by t raised to n minus 1, and n is equal to 1. Okay, so t raised to 1 minus 1, that is 0, and anything raised to 0 is 1. Do you know this? Anything to the power 0
Yes, sir.
is equal to 1. Okay, so this is 1, and that's why what do you get? dt by dt equals to 1. Derivative of t raised to 1 with respect to t is 1. Okay, similarly, if you take derivative of t square with respect to t, so what happens? Here n is equal to 2. Okay, so that 2 will come in multiple as a coefficient of whatever term we are left with. Okay, so we have this 2. Okay, it comes as a coefficient, it becomes coefficient, and the power of t reduces by 1. Okay, so it was t raised to 2, now it becomes t raised to 2 minus 1. 2 minus 1 is 1. Okay, and 1 we don't write generally. Okay, so it is 2 times t, right? 60.
Yes, sir.
How come 60? It will be 3t square. Okay, we'll go back, but before that, dt by dt is t cube. What will happen? See, this 3 will come as a coefficient, and power of t, which is 3, okay, it gets reduced. From n, it becomes n minus 1. So from 3, it becomes 3 minus 1, which is 2. So 3t square. All right. Okay, so let's go back. Okay, so you can say, Veera. So where are you saying you will get 60? Oh, is that okay? Okay, good. So this is how we find out derivative. Okay, so now this was simple stuff. Okay, but still uh, understanding this in terms of physics might be a little bit, it gets difficult for few students. Okay, but have you understood everything? So for derivatives, we have 2 points to be remembered. One point is when you draw some function, okay, some function of any variable, let's say. So when you take derivative of that function, what does it show on the graph? Okay, and how to find out derivative. So what is geometric meaning of the derivative? Okay, it is slope of the tangent line. Okay, derivative at any point is slope of the tangent line at that point. All right. Then second thing is how to find out derivatives. So this is the rule. This is the rule to find out derivative. This is known as what? This is known as the first principle of derivatives. Okay. So now are we going to apply this rule each and every time? So that answer to that is no. Okay. We'll just understand how to find out derivatives, and then there are lots of formulae. Okay, there are lots of derivatives that we need to memorize. Not There are not many. Okay, but there are few formulas. All right. So this is the take home message. Okay, so this is how we find out derivatives of algebraic functions. Now I will just ask you one question. So now let's say if x is equal to t square, okay, what is velocity of this particle or this person which is performing this motion, whose position is given by what? T square. Position as a function of time is given as t square. So what is the velocity at t equals to 2 seconds? So this is the direct question from NEET at least. Okay, and this is very important to understand for very perspective also. What will be velocity when t is equal to 2?
2 meter per second.
No, not 2. See, so we have seen what is velocity. We have seen it is dx by dt. So first do this. Okay, we have seen what is velocity. Velocity is instantaneous change in position with respect to time. Right? So change in position with respect to time will give you what? Average velocity. Okay, but if you want velocity at a particular instant, what do? You take instantaneous change in position with respect to time. Okay, that's what we saw, right? When time interval is very, very small. So it is derivative of position with respect to time. Okay, got it?
Yes, sir.
Okay, so it is dx by dt, derivative of position with respect to time. And what is x? X is t square. It is d by dt, I'm sorry, of t square. And what is t square? Sorry, what is derivative?
2t.
2t. It is 2
2t.
times t. And you want v at t equals to 2. So it is 2 multiplied by this t becomes what? 2. You want this velocity at t equals to 2. Okay. So this t becomes 2. So 2 times 2 is 4. Okay. Meters per second. If this is in meters. All right.
Yes, sir.
Okay. So what if x is equal to t cube? So let's put this on side. All right. So let's say A is this and B is position of a particle is given as x equal to half t cube. Let's say half t cube. Okay. So what is velocity at t equals to 2 seconds? So for A we did this. For B, what should we do? Same thing once again. Okay. What same thing? It is derivative of position with respect to time. Okay. So V equals to dx by dt. And what is x? D by dt of half of t cube is now x. Okay. So you can take this half outside. It's a constant. It's just a multiple. So you can take it outside of derivative. Okay. So you took half out. Then you have d by dt. That means derivative of t cube. And you know now what's that? What's that?
3t.
3t
3t
square.
square.
Okay, so 3t square. half of 3t square. Okay, yes. So when t equals to 2, when t equals to 2, this will become what? 4. T square is 4. 4 times 3 is 12. 12 by 2 is 6. Okay, good. 6 meters per second. So this will be, okay, 3 by 2 t square. So when t equals to 2, this becomes, or t equals to 2, this becomes v equals to 6 meters per second. So you understood how to find out instantaneous velocity given x in terms of t.
Yes, sir.
Okay, so it is derivative of x, derivative of position with respect to t. So first find out derivative, then substitute value. Okay, if you first substitute the value, then you won't be able to find out derivative, because if you just substitute, let's say, okay, if you put t equals to 2 here itself, then it becomes what? 8. 8 by 2. So now this is no longer a function. What has happened? When you substitute t equals to 2, you have taken a particular value of that function. So don't put the value first. Okay, first find out derivative, then substitute the value. Okay,
Okay, sir.
all right. So this is how we find out instantaneous velocity. Okay, and that's meaning of derivative. There are other terms also, but we'll see them as we go along. Tomorrow, what we'll do? Tomorrow we'll see trigonometric derivatives. Okay, so some trigonometric derivatives we'll see, and then we'll see rules on derivatives. All right, so let's stop.